Sometimes when we want to write an equation for a sinusoidal graph, we're given limited information. So how do we deal with only getting some coordinates for two different points, a high point and a low point, and nothing else labeled on the x and y axis? And notice there isn't even an x-axis here. This is the sinusoidal axis. The x-axis is way down here. My lowest y value is 25 and my highest is 75. So if I added the x and y axis, I'd actually have to go down way down here if I added the x-axis. So it's not even showing. So let's think about how the high and low points can help us find all four characteristics and allow us to write the sinusoidal equation. So we're going to start with sinusoidal axis. We know the sinusoidal axis is halfway between the high and low point. So let's identify on the y-axis the high point. Well, that would be our y-coordinate, 75, and down here our y-coordinate is 25. So our low point would be 25. So our middle point then is halfway between the high point and the low point. So we can think of sinusoidal axis as the high point plus the low point divided by 2. In other words, we can just average the high and the low points. So 75 plus 25 is 100 divided by 2 is 50. I could also say 75 minus 25 is 50. Half of 50 is 25. So the difference between the high and the middle is 25. So I could also think of this, okay, I know this is 50, so this has to be 25. And this has to be 25. So my middle value is 50, which is halfway between 25 and 75. So that's the sinusoidal axis. Of course, now that I know the sinusoidal axis and the high and low points, it's very easy to determine that the amplitude is 25. So using the y-coordinates of the two given points, you can find those two pieces of information. Now I need to figure out what I can learn from the x-coordinates of the points. So I have two x-coordinates, 105 and 255. So 105 to 255 would give me this distance from here to here. So if I do 105, or sorry, I should do it the other way around, 255 minus 105. 255 minus 105 is equal to 150. So this distance is 150. Now, if we look at this starting point where we've got this point, that would be the beginning of a cosine cycle, and the ending of the cosine cycle would be here. So I've gone halfway through a cosine cycle. So this is 1/2 of the period. If I wanted to go the rest of the way to the end of the cosine cycle, I would have to go another 150. So I know that the period is equal to 300. So the period equals 300. Let's go ahead and figure out the b for the equation. The b is going to be then 2 pi divided by the period, or pi over 150. So there's the b in the equation. So we have 3 of our 4 numbers. Now we need our phase displacement. And I want you to recognize that there are 4 different starting points I have marked. And I'm asking, let's write an equation for at each one of those, a cycle that starts at each one of those starting points. So we are going to start with starting point A here. And you might think, well, it'd be easier to start with B, and yeah, probably it would be. We already know a lot of information about that one, but let's start with A. If we start with A, notice that my point I'm starting with is on the sinusoidal axis. So I'm going to draw a little sketch here. There's the sinusoidal axis. I'm starting on the sinusoidal axis, so that means I also have to end on the sinusoidal axis. So my ending point is actually going to be right here. So there's my ending point. And I'll have one sine cycle. It starts on at point A, goes up to B, down to D, down to C, and then back up to whatever this point is. So here is what my cycle looks like. This is a sine cycle. So I'm going to write a sine equation. And I'm going to go ahead and write everything I know, and then we'll fill in the piece we don't know. So we know most of the equation already. We know the sinusoidal axis is 50 plus 25 for the amplitude sine of pi over 150 times x plus or minus something. So that's the part we don't know yet. I'll leave the parentheses open. That's what I don't know, is the starting point. So this is where we want to use the piece of information that we learned earlier, that all of the key points in the x direction are evenly spaced. So I know that from 105 to 255 is 150. So that means these 2 points from here to here must be 75 apart. And same thing with these 2 points. These must be 75 apart. That means these 2 also have to be 75 apart, and these 2 have to be 75. So that every time I have 2 key points, I could just keep going with this. So those are also 75 apart. Everything's 75 apart. So how many 75s have I gone with one cycle? Okay, I've gone 4 times 75. That gives me the 300. 75 plus 75 plus 75 plus 75. That looks like a 25, but that's supposed to be a 75. Now, I know that the x-coordinate of point B is 105. So I need to go 75 backwards from 105. So if I do this value right here, this is going to be 105 minus 75 equals 30. So my starting point is actually going to be at x equals 30 here. X equals 30. I wish I'd made this a little bigger. It would have been helpful. So this is going to be x minus 30 for the starting point. There's equation A. Now let's look at equation B. B starts at a high point. So we've already talked about that as a cosine cycle. So I'm going to make a little sketch of the cycle. It starts at a high point, so it has to end at a high point. Then it goes down to the sinusoidal axis, to its low point, back up to the sinusoidal axis. Curves, it's concave down above the x-axis, concave up below the x-axis. Or sorry, the sinusoidal axis. That's not the x-axis, that's the sinusoidal axis. So this is a cosine cycle. And we can write this, the only difference is going to be the phase displacement and using the word cosine in the cycle. So this is 50 plus 25 cosine of pi over 150 times x minus, and then our x value of the starting point is 105. All right, next we're going to do C. Point C is down here. It starts at a low point. So I'm going to extend my page up here a little bit so I have more room to write. It starts at a low point. That means it has to end at a low point. So if we start at point C, the end of the cycle would be way over here. So this would be my cycle from here to here. So let's make a little sketch of this cycle. Here's the sinusoidal axis. We're starting at a low point now. So when we start at a low point, then I'm going to end at a low point. And halfway up, halfway through, I'll be at a high point, and then I'll have my middle points. So looks like that. Notice the difference between B and C is that C has been flipped upside down. If you recall from our transformations earlier in the year, when we flip something upside down, it's because we've multiplied the outside of the function by -1. It's like f of x and negative f of x. So this is cosine, this is negative cosine. Now how do we make cosine negative? We multiply it by -1, but it's already been multiplied by 25, so we just change that to -25. So we have f of x equals 50 minus 25 cosine of pi over 150 times in parentheses x minus, and now we're looking at the x value of 255, so minus 255. So there's our other change. Last but not least is sine. Upside down sine. So if we start at point D, okay, that's a little harder to see over here, D, we're starting on the sinusoidal axis going down, up, back up to the top, and then back down again. So our cycle here starts on the sinusoidal axis, but instead of going up first, it goes down, then up, back to the middle, then up, and then back down to the middle. So it looks like this. So it's starting down instead of up. that means we have a negative sine cycle. So writing this is the same as what we just did before. We're going to make the amplitude negative. And of course we have to change the starting point or the phase displacement. So this is 25 sine of pi over 150 times x minus, and our starting point of this cycle, well, or d, we haven't figured that one yet. D is halfway between the x-coordinate, its x-coordinate is halfway between 105 and 255. So if this is 105 and we add 75 to it, that would be 180. So D has x equal 180. So this would be minus 180. So you can see that there's actually an infinite number of possible equations that I could write for this curve, but there are certain numbers that stay the same. The amplitude, the sinusoidal axis, and the period stay the same. What changes is whether or not it's sine or cosine, whether or not we're dealing with a positive or negative sine or cosine function, and of course the starting point of the cycle is going to be different for each one.